What's up, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neal Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, I want to welcome you guys to our first episode of our series entitled Math Teaser Alert, where we answer math questions that help you sharpen your critical thinking skills and your problem-solving skills. All right, so if there are no more interruptions, let's get into it. All right, so we have a question that reads, 3 semicircles with equal radii are drawn inside the large semicircle so that their diameters all sit on the diameter of the large semicircle. What is the ratio of the red area to the blue area? All right, so we have our diagram here where we have the blue semicircle, and there were 3 semicircles, as the problem says, with equal radii within it. And we want to find out the ratio of the blue area to the red area. All right, so here's how to answer such a problem. So what we're going to do is to find out the radius of all these parts, because we need that in terms of finding out the area of the blue and the red. So remember, a radius is half the diameter of a circle. It starts from the center and goes to the edge of that circle. So the small red one here, the center of it would be about here. And if you went all the way to the edge, it'd be over here. So that would be a radius. So I'm going to call that radius X for now. And now that we have a representation for it, we can then find the area of that circle by using the equation of the area of a circle. Well, semicircle in this case. So let's say we want to find the area of the red. Okay, so the formula for the area of a circle is pi r squared. Okay. But because it's a semicircle, so half of a circle, this would be the formula for the entire area, but we want half of it. So half of something is always dividing by 2. So we can just take this thing and divide by 2. And that'll be the area of the red semicircle. All right, since our radius is x, we just replace this r with that x. So it would then become pi x squared divided by 2. So this would be the representation of half of the area of the red circle. The red circle that you see on the diagram here. But one more thing we have to consider is that we have 3 of them. There were 3 semicircles within this diagram. So since this expression here is the area of just one of them, multiply this thing by 3, and that'll be the area of all 3 of them. So that then becomes 3 pi x squared divided by 2. So this is the area of all 3 red semicircles. Right? So far, so good. Now, let's see if we can find the area of the blue. So we'll use the same technique. So we need to know the radius of the blue circle. So we can use what we know about the radius of the semicircle, of the red semicircle being x. So if you were to apply this all the way through, that piece is x, and then, let me use a different color rather. From here to here is x as well. So the diameter of the red semicircle would be 2x. So 2x plus 2x plus 2x would be 6x. So 6x would be the diameter of the blue semicircle. So 6x in total. And since half of a diameter is the radius, half of 6x would be the radius of our blue semicircle. So divide this by 2, you get 3x. So that means the radius of our blue semicircle happens to be 3x. And now we can find the area of the blue part. So area of the blue would be equal to the same formula. So pi r squared divided by 2. All right, and since our radius happens to be 3x, as we found out before, we replace our r in the equation with that value and just simplify. So when we replace it, it becomes pi times 3x, that quantity squared, divided by 2. Okay? Now we have to square that, 3x squared. So 3 times 3 is 9, and x times x is x squared. So putting it all together, you get 9 pi x squared divided by 2. And this would be the area of the blue semicircles. But hold on, we have a problem. This particular value would include the 3 semicircles within it, because the 3 semicircles are inside the blue semicircle as well. So we have to remove this area, these 3 semicircles, from the area of the blue semicircle to be able to actually find the real value of the blue area. Because the blue area is actually just what you see shaded here, just the parts above it, not the red part as well. So we have to remove that. So the way to do that is to subtract the 2 values from each other. Take the blue area, the entire blue semicircle, subtract the red areas that we found out, and that'll give you the rest that is blue. So our area of the blue was 9 pi x squared. Our area of the red was 3 pi x squared. So we can just subtract those 2 values from each other. So let me do it down here. 9 pi x squared divided by 2 minus 3 pi x squared divided by 2. All right, so that's our subtraction problem. And when we subtract these 2 values from each other, we notice that the one difference is the 9 and the 3. Everything else is the same. So we can just subtract those 2 numbers and everything else will remain the same. So 9 minus 3 is 6. So 6 pi x squared divided by 2 would be the result. But we can simplify. We have 6 on top and 2 on the bottom of our fraction. So it literally says 6 divided by 2, which is 3. So the value actually becomes 3 pi x squared. And 3 pi x squared is the actual value of the area of the blue part that's within that semicircle. So now that we have the area of the blue and we have the area of the red, which is up here, area of the red is this, area of the blue we found out to be this value down here, actually. The question is asking for the ratio of the blue area to the red area. So the blue area comes first, and then the red area comes second within that ratio. So the blue area was this, 3 pi x squared. So that's on top. And the area of the red is 3 pi x squared divided by 2. So 3 pi x squared divided by 2. All right, so we have a fraction within another fraction, specifically in the denominator of that fraction. So that we have to simplify this fraction if we can. All right, so anytime you have a fraction within a fraction, basically you're dividing fractions. And the way to do that is to take the reciprocal of the second fraction and just multiply like you normally would. So the reciprocal of this fraction, 3 pi x squared divided by 2, reciprocal means flip, so you just change the positions. 2 goes on top, and 3 pi x squared goes on the bottom of that specific fraction. So that then becomes, let me do it down here, 3 pi x squared times 2 over 3 pi x squared. So we have a number times a fraction. So it looks a little weird to handle right now, but what we can do is turn this value into a fraction by putting it over 1. So that over 1. And now we can actually simplify this fraction a lot simpler by paying attention to the values on the top and the bottom. This value and this value, 3 pi x squared, are the same on the top and the bottom. So it's just like dividing the same thing. 5 divided by 5, 18 divided by 18, it's always 1. So basically that cancels out, and so does that, and becomes a 1. So the ending result becomes 2 over 1. And that would be the ratio of blue to red. Oh, the question is asking for the ratio of red to blue. I'm sorry. So it'd be the reverse version of this. My apologies. It would be actually 1 over 2. Since I flipped the order of the areas, it was, I put it as blue to red when it should have been red to blue. So I should have flipped it, which means this has to flip as well. So it becomes 1 over 2. So 1 over 2, is the actual area, ratio of the red area to the blue area. And that's how you go about solving this particular math question. All right, so I hope you guys enjoyed that video. I hope it lit a fire for your passion for learning and mathematics. Don't forget to like, share, comment, subscribe, and follow all of our social media pages, our Facebook, our Instagram, and our YouTube. And I will catch you guys in the next episode.